So now let's look at our fourth example here. I have 3 minus the square root of 21 all over square root of 7 minus the square root of 3. Again, we haven't seen one like this with two radicals in the denominator with our binomial, but we're still not going to change anything about using our conjugate, so it's going to be square root of 7 plus square root of 3. And again, I'm going to multiply by distributing just like normal. So 3 times square root of 7 is going to be 3 square root of 7. 3 times square root of 3 is going to be 3 square root of 3. Negative square root of 21 times square root of 7 is going to give me a negative square root of 147. And negative square root of 21 times positive square root of 3 is going to give me a negative square root of 63. And that's going to be all over. Again, I'm going to do my first, so square root of 7 times square root of 7 is 7, and my last of negative square root of 3 times square root of 3, which I get a negative 3. And so now what I need to do is I need to break up the 147 and the 63. So the one thing is, a lot of times with 147, it freaks people out, like what could go in there? Well, think about what got you 147. 21 times 7 got you that 147. So I'm going to write what I multiplied to get 147. And then here I have 3 and 7. So I'm able to take out a 7. So this is going to be 7 square root of 3. And then I'm going to do the 63. So you can even do the 21 times 3 if you want, or 9 times 7, whatever you find. But I'm just going to stick with my plan of I did 21 times 3 to get 63. And then I have 7 and 3. So I'm able to take out a 3. So that's going to be 3 square root of 7. And so now I'm going to rewrite this numerator of 3 square root of 7 plus 3 square root of 3 minus 7 square root of 3, okay, minus 3 square root of 7. So I'm bringing those guys in. All over 7 minus 3 is 4. So now at this time I want to combine like terms. So if I notice here, the 3 square root of 7 and the negative 3 square root of 7, those are gone. And then I have 3 square root of 3 minus 7 square root of 3. So I end up getting negative 4 square root of 3 all over 4. And then I'm going to look here. So this is different because I just have a monomial in the numerator rather than a binomial. But I'm still going to look at what's outside with the negative 4 and 4. I can divide each of those by 4. And so when I do that, I'm just going to put my answer here so I don't have to go to a new screen. When I divide negative 4 by 4, I get a negative 1, so that's going to be a negative square root of 3. And then 4 divided by 4 is 1. I don't need to write that in the denominator. So my final answer will be negative square root of 3. Now let's look at our final one. This one could be a little bit of a doozy, but it's actually nothing different. It's just a little bit more work. That's all. So I have 9 over 2 square root of 3 minus square root of 2 minus 6 over 2 square root of 3 plus square root of 2. So what you'll notice, this is a subtraction problem with fractions. Anytime you add or subtract fractions, you do need to find a common denominator. These are not common, but what you'll notice, they are conjugates of each other. So actually what we're going to do, we're going to rationalize both of them separately and then bring them back together. The one big thing that I like to make known is that this is a subtraction problem, and a lot of times it gets lost in all of the conjugations that the rationalizations that we do. So what I'm actually going to do is I'm going to change this to an addition problem and then distribute that negative to the numerator. Okay, and you have to distribute it to the entire numerator, but there's only one term here, so just the 6 gets its sign changed. So now I have 9 plus negative 6 in the numerator. And so what I'm going to do is I'm going to label this 1 and 2, and then I'm going to have my 1 and my 2 here. So that way I'm going to come back and fill this in after I rationalize. So let's rationalize our first one. Our first one, we have 9 over 2 square root of 3 minus square root of 2. So I need to utilize the conjugate of 2 square root of 3 plus square root of 2. And then I'm going to distribute. So 9 times 2 square root of 3 will give me an 18 square root of 3. And then 9 times square root of 2 will give me a 9 square root of 2. Okay? Then in my denominator, I'm going to do 2 square root of 3 times 2 square root of 3. It is very, very important that you multiply this correctly. I first need to multiply 2 times 2, which is 4. And then I have to do times square root of 3 times square root of 3, which is 3. Okay, it's very, very important, and a lot of people mess this up. I can even make that mistake sometimes too. I'll see 2 times 2, and I'll say that it's 2 instead of 4. So it is very important that you pay very close attention to every slight little detail here. And then I have negative square root of 2 times positive square root of 2, and that's going to just be a minus 2. And so now at this time, if you notice in my numerator, there's nothing that I can reduce inside the radical. There is nothing, no like terms that I could add. So my numerator is actually just going to stay what it is, 18 square root of 3 plus 9 square root of 2. And then I know 4 times 3 is 12, so I have 12 minus 2, which is 10. Now, normally, with any kind of problem like this, I would check the 3 numbers and see, do I have something in common that I can reduce with? However, with a problem like this, because it is an addition or subtraction of fractions problem, you don't want to reduce until the very, 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 very end, okay? So even if these 3 had something in common, like 2 or 4 or 3 or something like that, you still don't want to reduce until the very, very end. So this is going to be the answer to my number 1. So that's what I'm going to write here. 18 square root of 3 plus 9 square root of 2 all over 10. So now let's move on and let's rationalize the second one. So I had negative 6 over 2 square root of 3 plus square root of 2. And so now I need to multiply by the conjugate, 2 square root of 3 minus square root of 2, and 2 square root of 3 minus square root of 2. And then I'm going to distribute. So negative 6 times 2 is negative 12, and then that's going to be square root of 3. And negative 6 times negative square root of 2 is going to be a positive 6 square root of 2. All over, and again, when I distribute, I have to do 2 times 2, which is 4, times square root of 3 times square root of 3, which is 3. And then it's going to be positive square root of 2 times negative square root of 2, which is just going to be minus 2. So again, in my numerator, nothing that I can simplify, no like terms. So my numerator is going to stay as negative 12 plus 6 square root of 2 all over, and then this is going to be 12 times 2, which is 10. So again, notice these 3, normally I'd look at it and be like, oh, they all have 2 in common, let's reduce. Not in this case, because this is not my final answer. I still have to add it to my part 1. So this is going to be my answer to part 2. So let's go back here and let's write in that answer of negative 12 square root of 3 plus 6 square root of 2 all over 10. So now at this point, I have an addition of fractions and I have common denominators. So now I'm going to write my answer with my common denominator of 10, and I'm going to combine any like terms. So I have 18 square root of 3 plus negative 12 square root of 3, and I'm going to get a 6 square root of 3. I have a 9 square root of 2 plus a positive 6 square root of 2, and that's going to give me 15 square root of 2. Now at this time, I check all 3, and none of them have anything in common, so this truly is my final answer to my original problem. One other thing that I want to reiterate, this was one where I did have a binomial in my numerator. There can be times where you might have a monomial in your numerator, and it might just turn out to be a normal fraction like you're used to seeing, like 1/2 or 3/4 or 5/6. It could be something like that. So don't get thrown off if you don't end up having a binomial in your numerator. It all depends on what the numbers are given.